Welcome to the 14th lecture in Riparian Function and Management. Our previous lesson covered some key considerations in understanding general riparian management. By understanding the surrounding land use, one can determine the riparian management practices and techniques necessary to create guidelines for a variety of land use types, in which we discussed cropland, pasture land, range land, forest land, urban land, and recreational land. Today, we will apply that understanding as we learn about riparian management issues. Today's discussion will address some common riparian management issues that may challenge managers. Riparian management issues include fragmentation in riparian areas, grazing management in riparian areas, management of native and exotic wildlife, retaining large wood, management of exotic riparian plants, riparian management downstream from reservoirs, and engineered solutions. Larger ecologically intact properties under sustainable management for multiple generations has been a keystone for sustaining intact watersheds and functional riparian areas. The recent trend toward dividing large tracts of rural land into smaller and smaller tracts is a significant conservation issue in Texas and is especially critical for riparian areas. The progressive selling and subdividing of large tracts into smaller units often places increased human, livestock, and infrastructure pressure on natural resources. As land in riparian areas become more divided, it creates much greater challenges for sustainable management and for maintaining ecological function. Reducing the rate of land and riparian fragmentation through conservation easements is an effective way of addressing this problem. Conservation easements, developed with the assistance of private land trust organizations, provide incentives and guarantees to keep larger land units intact. Conservation easements are customized to meet the needs and desires of individual landowners, but they all have provisions to restrict future subdivision and development of the property. Conservation easements are neither a transfer of ownership nor a grant of public access. Landowners who established conservation easements with the land trust maintain ownership and the ability to continue using the property as in the past, including farming, ranching, hunting, and recreational activity. A conservation easement simply restricts future development regardless of who owns the land in the years ahead. Conservation easement plans outline land and riparian management practices mutually agreed upon by the landowner and the land trust. Livestock grazing has been the most widespread and predominant use of land in Texas since the 1800s and has affected almost all creeks and rivers in the state. During the early years of the Texas livestock industry, stockmen had little understanding of or interest in sustainable grazing management. In recent years, many ranchers have taken a much deeper interest in proper grazing management, including riparian management. More riparian areas can be positively or negatively affected by grazing management than by any other single land use practice. The impact of grazing on riparian vegetation can be understood by this simple fact. One full-grown cow will consume approximately 10,000 pounds of vegetation each year on a dry weight basis. Even a few cows can have a significant effect on vegetation if they stay in comparatively small riparian areas for a long time. The key to sustainable grazing in riparian areas is the timing, duration, and frequency of grazing and the length of recovery between grazing periods. Parts of Texas support large numbers of native deer and/or large numbers of exotic hoofstock. Where deer and exotic numbers are not properly managed, they can cause significant damage to riparian vegetation. When their numbers are kept in balance, good riparian conditions can be maintained. White-tailed deer, which are abundant in many parts of Texas, consume primarily browse and forbs. Their primary effect on riparian areas is the browsing of riparian shrubs and trees, especially seedlings and small plants. Excessive populations of deer can essentially eliminate the reproduction and recruitment of key riparian shrubs. Deer also graze several species of important riparian forbs, including water willow, goldenrod, watercress, water hyssop, and water primrose. Fortunately, white-tailed deer do not readily consume grasses or sedges, and therefore have little effect on this important class of riparian vegetation. Deer densities in riparian areas are often 5 to 10 times higher than adjacent upland areas. During drought, the disparity is much greater as deer populations shift toward the riparian areas in search of forage and water. Monitoring of browsing on woody plants is an important aspect of riparian management. Managers can learn to recognize the visual signs of hedging and the development of browse lines and use this information to help guide deer herd management. Axis deer are the most common and most troublesome species of exotic deer because they naturally congregate in riparian areas. In central Texas, for example, it is common to see groups of 20 to 50 or more axis deer traveling up and down riparian areas. Axis deer consume all classes of riparian vegetation, including grasses, sedges, forbs, and woody plants. For this reason, they can cause extreme overgrazing and overbrowsing of riparian areas. The damage caused by excessive numbers of axis deer is severe on many miles of the Edwards Plateau creeks and rivers. Options for the management of exotic deer include aggressive hunting and trapping, and/or the construction of high fences to exclude them from riparian areas. Axis deer and other exotics are not regulated game species, and they may be legally hunted at any time of the year. Other common species of exotic deer include fallow deer, sika deer, red deer, and elk. Several less common species of deer can also be found. Many species of exotic antelope and sheep are also found in Texas, but they are not generally causing widespread damage to riparian areas. Feral hogs are widespread in Texas, and their numbers are range in increasing numbers as well. The primary riparian damage caused by feral hogs is physical damage by their destructive rooting habits. Hog wallows can cause extensive damage to banks, seeps, springs, and wet areas. Sediments disturbed by hog rooting and wallowing are easily eroded away, often causing further erosion. The best time for riparian managers to begin hog control efforts is when the first hog is observed. Relentless and perpetual trapping, shooting, and other control methods will be needed to reduce hog numbers in some areas and to reduce riparian damage. In recent decades, one of the most relevant riparian discoveries is the importance of large wood for the proper function of many creek and river systems. Large wood refers to logs and dead trees that fall or wash into the channel, banks, and floodplain. Some washed-out trees may float long distances before they are caught on point bars or other channel obstructions. Other trees become trapped near where they fall, especially if they are living trees or shrubs to help hold them in place. The attached root wad often helps anchor large wood in place initially until it can become incorporated into the sediment. Once these large trees become lodged and locked into place, they begin to provide many important and diverse functional benefits to the riparian area. Large wood provides effective energy dissipation during high flow events and begins to trap sediment much like a retaining wall. Eventually, many logs become partially or completely buried in sediment, where they become structural components of the channel. The presence of large wood buried in the channel is likened to rebar that strengthens and reinforces concrete. Research across the United States and in other countries has shown that buried wood remains intact for hundreds and even thousands of years. Large sunken wood has been routinely removed from creeks and rivers across North America for the past 200 years for economic and navigational purposes. Many riparian systems have been damaged by the removal of wood, and the natural restoration of suitable amounts of wood will be a very long and slow process. Many Texas landowners and some riparian managers still remove logs and fallen dead trees in the misguided belief that creeks need to be cleaned out. This is usually done with good intentions, but without understanding the inevitable side effects. By removing or burning the wood, they are also speeding up the flow of floodwater, which increases erosion, damages banks, and undermines channel stability. By leaving the large wood in place, landowners and managers will help dissipate energy, slowing down the water, reducing erosion, trapping sediment, and building bank stability. There are some cases where large wood should be managed, for example, when it presents a safety hazard to bridges or other infrastructure. However, in the vast majority of cases, large wood should be left in place and recognized for the necessary benefits that it provides. Riparian landowners can learn to appreciate the natural value of wood, even though some consider it unsightly. Exotic plant species often find their way into riparian areas. This is especially true in the urban riparian areas and downstream from urban development. Many of the exotic species now commonly found in riparian areas originate from residential landscapes. Not all exotic species found in the riparian zone are problematic. Problems can develop when plants aggressively reproduce and when they tend to dominate and monopolize the area at the expense of native species. Some of the common exotic plant species which are causing problems along Texas rivers and creeks include waxleaf ligustrum, Chinese privet, Chinese tallow tree, salt cedar, Russian olive, China berry, giant cane, Japanese honeysuckle, elephant ear, lilac chastity tree, and water hyacinth. Control or management of aggressive exotic plants may be warranted where the species is known to rapidly reproduce and displace native riparian vegetation. The challenge is to find control methods that are selective and specific to the target species without harming nearby native plants. This kind of work is tedious, laborious, expensive, and slow. Often, the most feasible approach is the individual treatment of plants with bark-applied or foliar-applied herbicides that are labeled for that purpose. You often will have to treat an area several times to achieve adequate levels of control. Localized control efforts by individual landowners can be very frustrating when upstream control efforts are lacking. When upstream seed sources or reproductive matter are not addressed, recurring problems can be anticipated. This effort reinforces the importance of cooperative riparian management by many adjoining landowners. Where isolated and scattered patches of exotic plants are found, and when future problems are anticipated, it is strongly advisable to begin control efforts early rather than wait for populations to expand and increase in density. Regular scouting of riparian areas for early detection of problematic plants is an important aspect of riparian management. Riparian managers should be able to identify the exotic plant species that are found in their region and to seek assistance on effective control methods. Extensive control of dense stands of exotics can backfire with unintended consequences if not carefully planned and executed. In some cases, exotic plants may be the only vegetation holding the banks together. So, if removed all at once, the banks in the floodplain become extremely vulnerable to damage. One of the first cardinal rules in riparian management is, first, do no harm. A bank protected by unwarranted exotic species is actually better than an unstable, eroding bank. For example, some riparian areas in West Texas are totally dominated by salt cedar, which is doing a good job of stabilizing banks and channels. If the salt cedar is killed all at once, then the bank becomes vulnerable to severe erosion during high-flow events. Similar examples have been observed with waxleaf ligustrum and giant cane, otherwise known as Arundo. Where dense monocultures of exotic plants exist, managers are urged to take a progressive, incremental approach rather than an aggressive or extensive approach. Control can begin in small pockets, not large areas. Control pockets will be surrounded by intact exotic vegetation. Monitoring the natural regeneration of native plants into these pockets is an important part of exotic plant control projects. If desirable native plants begin to establish within the pockets, continue control efforts with additional pockets. As native plants begin to grow and provide the needed stability, the size of the control pockets can be enlarged. This approach helps to retain root stability and energy dissipation and reduces the vulnerability of the control project to severe erosion. The gradual increase in the size and number of control areas can occur until the exotics are removed and replaced by the natives. Several years of follow-up control and maintenance will be needed in most cases to kill new seedlings, root sprouts, or plants previously missed. If natural regeneration of desirable native riparian plants does not take place, managers will need to find a plan for the artificial replanting of the desired vegetation. Some non-native plants can also add functional value to the riparian area and should not automatically be viewed as detrimental. Watercress, pictured here, is providing sediment-trapping qualities in a tiny headwater stream. While others might fill a similar niche as native plant species without dominating the riparian area or displacing native species. Although native riparian plants are almost always preferred, it is neither realistically possible nor economically feasible to attempt to control any or all infestations of exotic plants. Riparian areas that are located downstream from major reservoirs often present special challenges for management. Due to the nature of reservoir management and releases from the floodgates, problems often occur which are out of the control of downstream landowners. The common situation across the western half of Texas is little or no release below dams for months or even years at a time. All normal inflow is detained in the reservoir, and natural bankful or out-of-bank flow rarely occurs. As a result, the alluvial water tables may no longer be recharged. As the water table is lost or greatly reduced, riparian wetland vegetation cannot survive, and vegetation may slowly change to non-riparian species. The effect of the dam may be a major long-term shift from riparian to upland conditions, even in close proximity to a channel. If and when abnormally large rainfall is received and reservoirs fill, large releases are made, but without intact riparian vegetation, the large sudden releases typically result in severe downstream erosion. For the wetter part of Texas, where constant releases usually take place below dams, the problems are much different. In these situations, an artificial base flow exists most of the time. Larger flows may take place periodically to keep reservoir levels at the desired stage. When large rain events occur above the reservoir and when lake levels rise, reservoir managers dump huge volumes of water out of the floodgates or spillways. It is common for these large releases to persist for days or weeks. In some ways, these flows mimic large natural flood events, but they usually last much longer than natural flood flows. When lake levels have been reduced to the desired stage, reservoir managers close the gates and water levels drop immediately. Saturated banks, which have been underwater for extended periods, are suddenly exposed, which causes severe bank sloughing. Another important problem exists for releases below reservoirs. Reservoirs trap upstream sediment, and water released from reservoirs lacks sediment. This lack of sediment creates what is known as hungry water, which is more erosive than water with a normal sediment load. Downstream landowners can do everything right with their riparian management and still have severe problems. The retention of dense natural riparian vegetation and large wood will help minimize the damage that is often caused by sudden and prolonged releases followed by rapid drawdown. A desirable solution would be to work with the reservoir managers to manage these releases to more closely approximate the frequency, intensity, and recession of natural flows. In some deteriorated creek and river areas, the damage has been so severe that intensive engineering solutions are sought to help restore desired conditions. These fixes are extremely expensive. In most cases, the only ones that can afford such costly solutions are government entities. Very few private landowners are able to justify this expense. These intensive restoration projects require specially trained engineers who have expertise and experience in hydrology, fluvial geomorphology, stream processes, vegetation, permitting, and working with large equipment operators. The size and scope of these expensive urban riparian restoration projects serve to illustrate how society is beginning to understand the values produced by a functional natural riparian area. Engineered solutions are often expensive and carry a high risk of failure. Pictured here is a well-engineered, successful restoration project. After a number of riparian plantings failed, the site was secured from exotic wildlife by installing a high fence, where vegetation began to succeed. There are relatively few engineers in Texas who currently have this kind of experience. Civil engineers who do not have the necessary specialized training are more likely to recommend hard engineering practices such as concrete, riprap, gabions, grade control structures, and other traditional solutions. Experienced riparian and stream restoration engineers learn to work with the natural dynamics of the creek rather than force rigid structures into a dynamic system. They try to re-establish normal channel dimensions, sinuosity, slope, velocity, and sediment transport, paying special attention to the critical role of the floodplain and the stabilizing vegetation. The use of cross vines, J-hook veins, and other similar structures composed of large boulders and/or logs helps direct high flow energies to the center of the channel rather than to the banks. These kinds of structures, although artificial, augment the natural process of stream equilibrium and help banks to establish appropriate vegetation. With time and the development of vegetation, many of these structures blend in and are hardly noticeable. Today's lesson introduced some common riparian management issues. These issues can include fragmentation in riparian areas, grazing management in riparian areas, management of native and exotic wildlife, retaining large wood, management of exotic riparian plants, riparian management downstream from reservoirs, and engineered solutions.